Okay, buddy, here we go. Let's go ahead and review. So these trig equations are getting a little bit more difficult, a little bit more tricky, so we have to use our identities along with just our unit circle and our reference angle chart as well. So first of all, solving trig equations with the help of identity. So number one, here it is. You get a sine, 2 sine equals a cosine. So what you have to do is you can't change a sine to a cosine, but if you can make it into a tangent, divide by cosine, you change the whole thing into a tangent. So then, instead of 2 different values, you wind up with a tangent. And then you just solve, divide by 2, tangent equals 1/2. I use my calculator in radian mode. I went tangent inverse of 1/2, and I got about a 0.46. There are 2 answers because we're going from 0 to 2 pi. So the reference angle charts to take pi plus that angle, and I got about a 3.605. So here's my 2 angles that work, okay? Number 2. Well, it's even more complicated, but what I do is I looked at the algebra here and I thought, well, how do I solve for this? So I brought the 3x over and I common factored. That's algebra. We're going to do the same thing. Brought this 3 sine over. I subtracted 3 sine. I recognized that I could common factor out a sine. Pull that a sine out of both. I'd have a tangent minus 3 left over. I have many equations now. They're different, but they're many equations. Sine of x equals 0 and tangent of x minus 3 equals 0. Now, sine of x equals 0, that's on the unit circle. Sine's the y value, happens here, and it happens here at pi and 0. Tangent equals 3, I'd use my calculator, and I got tan inverse of 3, and I got a 1.25 as my third angle. To get the reference angle, I added pi to it, and I got about 4.39. Okay, let's turn the page. Now this is one big, huge problem, but let's take a look at it, okay? So, hint, square both sides. So I have to square both sides. So what I did is I squared it, and I wound up with squaring both sides. This becomes then a 4 sine squared of x. To square this, I have to write it twice, because it's self-squared, and I had to FOIL. Cosine squared, plus a 1 cosine, plus another 1 cosine, plus 1. Combine these two, and I got a 2 cosine of x. Now, problem is I have cosines and sines, and I can't change these cosines into a sine, so I changed my sine squared. An identity I have from the last few days is I know sine squared is equal to 1 minus cosine squared. So now I'm going to make this substitution. It's a hard problem. So make that substitution, then everything's in terms of cosines. Okay, well then I'm going to go ahead and multiply 3 by 4, 4 minus 4 cosine of x. I need to make it equal to 0 because I'm thinking I'm going to have to factor. So to make it equal to 0, I add a 4 cosine. Add a 4 cosine squared, sorry. 5 cosine squared. I subtracted 4 from both sides, gave me a negative 3. That's a minus 4, sorry. And then I wound up with 5 cosine squared plus a 2 cosine minus 3. Now, this will factor, and I did the factor with algebra. 5xx, 3 and 1. If I do my 5x and my negative 3x, it makes the 2. So instead of x's, though, it's really cosine. So I did a little bit of algebra here, so then I can come and rewrite it in terms of cosines, right? So I got a 5 cosine of x minus 3 and a cosine of x plus 1. And then I have my mini equations. 5 cosine of x minus 3 equals 0. And I took my other mini equation, cosine of x plus 1 equals 0. And then I solved. Plus 3 divided by 5. Well, that's not on the unit circle, but I can use my calculator in radian mode. Cosine inverse 3/5 is 0.927. And then the reference angle is to take 2 pi and subtract it from my theta 1. And I wind up with my other angle, which is about a 5.36. Second one, just solve the last equation, minus 1. Cosine of x equals negative 1. Happens right here, x's cosine, which is at pi. Okay, that's all I had. We're going to do 9 to 16 all. They're kind of complicated. It takes a little bit of factoring and manipulating, but work on them. We'll look at them in class tomorrow if you like. Okay, so that's all I got.